Balancing Equations Part 4, Double Replacement Reactions. In a double replacement reaction, the ions swap partners. For the reaction to occur, one of the following must happen. An insoluble product forms, a gas forms, or unionized product like water forms. Hint: when balancing double replacement reactions, balance the atoms in this order: metals, nonmetals, polyatomic ions, hydrogen next to last, and oxygen last. The double replacement reactions, you have a compound plus a compound yields a compound plus a compound. One of them has to be insoluble, so we check our solubility rules to see if that happens, or water is formed or a gas is formed. These charts will be available on the quiz. Example 1. Use the balancing equations flowchart to determine the type of chemical reaction and to balance the following equation. I have a compound plus a compound yields a compound plus a compound. This is a double replacement reaction. In a double replacement reaction, the outside goes together and the inside goes together. And make sure on the right side that the positive ion is written first in the compounds. Writing down what we know, we have 2 sodium, 1 carbonate group. The carbonate groups stayed together, so we're going to balance it with it together. It makes it a little bit easier. 1 aluminum, 3 chloride. On the right, 1 sodium, 3 carbonate, 2 aluminum, and 1 chlorine. We're going to start by balancing the aluminum. We place a 2 in front of aluminum chloride, and now we have 2 aluminum, and 2 times 3 is 6 chlorines. Let's balance the carbonate. We put a 3 in front of the sodium carbonate, and we find 3 times 2 is 6 sodiums, and 3 times 1 is 3 carbonates. Our carbonate is balanced, our aluminum is balanced. We place a 6 in front of the sodium chloride, and the equation is balanced. Does the reaction occur? One of the products, either sodium chloride or aluminum carbonate, must be insoluble. Carbonates are insoluble. The reaction does occur. 3 sodium carbonate plus 2 aluminum chloride yields 6 sodium chloride plus aluminum carbonate. And the reaction occurs because aluminum carbonate is insoluble. Example 2. Use the balancing equations flowchart to determine the type of chemical reaction and to balance the following equation. We have a compound plus a compound yields a compound plus a compound. This is a double replacement reaction. In a double replacement reaction, outside goes together, silver goes with the phosphate, insides go together. Potassium goes with the nitrate. Make sure you write the positive ion first on the right side of the equation in the compounds formed. Writing down what we know, we have 1 silver, 1 nitrate, notice the nitrate group stay together, 3 potassium, and 1 phosphate on the left. Again, the phosphate stayed together. On the right, we have 3 silvers, 1 nitrate, 1 potassium, and 1 phosphate. So let's balance the silver first. I put a 3 in front of the silver nitrate, so I have 3 silvers and 3 nitrates. Now let's balance the potassium. I put a 3 in front of the potassium nitrate. The equation is now balanced. Does the reaction occur? Water didn't form and a gas didn't form. So either silver phosphate or potassium nitrate has to be insoluble. In general, nitrates are soluble. Phosphates are not. The silver phosphate is insoluble, it forms a solid, or what they call a precipitate, the reaction will occur. The final balanced equation is 3 silver nitrate plus potassium phosphate yields silver phosphate plus 3 nitrates. And the reaction occurs because silver phosphate is insoluble.